A lot of compounds in chemistry can look very similar to each other. There's a lot of solid compounds that are white. There are a few colored ones, and there's an awful lot of clear solutions and liquids that you may have seen in the lab. So how do scientists tell what those different things are if, say, a label comes off, or if they've been given a sample of something maybe taken out of the environment, and they're supposed to test to see what's in that sample? Qualitative analysis is a way of using physical properties of compounds to help in the identification of what's present in that mixture. There are a few different ways that you should be able to distinguish different compounds from each other. The first one we're going to look at is the color of solution. There are some ions that have a very distinctive color when they're in solution. And if you look on page 11 in your data booklet, you'll see quite a few examples there. If you find copper 2 in that list, you'll notice that it says blue to pale blue when you look at the different concentrations that it gives you. Generally, if you see this in the lab, it will be somewhere between those two concentrations, the 1.0 and 0.01. So generally for copper, we can say it's going to look blue. Iron 2 says lime green to colorless. So lime green is what you would notice. It's not necessarily going to be really bright, but you should notice a distinct green color. Iron 3, the other iron charge, has a different color. It's orange to yellow. So it's very easy to tell those two apart if you see them in solution, even though one of them is a 2+ charge and one is a 3+. The permanganate ion, MnO4-, is right at the very bottom of your table. And this is a very deep purple color. It's a very concentrated or bright and intense color, so even at very dilute concentrations, permanganate is easy to distinguish because of its very intense purple color. The second thing you should be able to recognize as a property and help to distinguish between different elements is a flame color. And in the lab, you'll actually get to test some of these out. So many of the metals and a few non-metals have a very distinct color when they're heated or burned in a flame. And again, in your data booklet on page 6, there's a chart or table that will help you with this. Copper, when it's in solution or in solid form and is put into a flame, will produce a blue or green color. Potassium forms a violet color. Calcium, according to your chart, will be yellowish red. So that's not orange. You'll actually see parts of the flame that look a bit more yellow and parts that look more red. And barium says is yellowish green. So again, you'll see sort of some parts that look yellow and some that look green. A third way that you can help distinguish what's in a solution is to form a precipitate. When certain ions are mixed together, they form insoluble compounds or precipitates. And this is the chart that's on the top of page 6 in your data booklet. You've already used it before to help figure out states during reactions. If an ion is suspected to be present, a solution containing another ion that would form a precipitate is added to it. And if we see any cloudiness, that means that a precipitate has formed. So we're going to say that a student thinks that a colorless solution contains barium ions from a flame test. So again, from that flame test, if you look at your chart on page 6, barium would show a yellowish green color, and so would boron. So for whatever reason, the student thinks it contains barium. To help confirm this, they want to add a solution that will form a precipitate to help support their what they suspect. So using your solubility table at the top of the page, you would want to find an anion across the top that would form a precipitate with barium. And you've actually got lots of choices. So a solution could contain the fluoride ion, so maybe it would be sodium fluoride. Or it could contain a sulfate ion, because under sulfate we see that barium is in the bottom box and therefore would form a precipitate. So maybe something like potassium sulfate, K2SO4. And even the ones to the right of that, carbonate and phosphate, would also form precipitates. So there's actually lots of answers you could give for this question. Ammonium carbonate would be another example. And we could go on and on, but you get the idea.